I had a lot of really good questions yesterday about how to do electron configurations efficiently. And so I found myself reminding people about some of the shortcuts you can use on the periodic table to do electron configurations. And I thought it might help if I just did a quick review. So when you look at the periodic table, if you're going to use it to do an electron configuration, it's worth dividing it into the S, P, and D groups. S is group 1 and group 2. P is all of the groups on the right-hand side of the periodic table, and D is our transition metals. There's also the F group, the lanthanides and actinides, but we're not going into that in our class. I can further break this down by thinking about the individual electrons that would go into an electron configuration. The first group is S1, the second group is S2. In the P group, I have P1, P2, P3, P4, P5, and let's erase helium from here and just talk about P6 being that last group. The reason I scribbled out helium is for electron configurations, we should really think about it as being an S2. In the middle, I've got my transition metals. These are the Ds. I can have up to 10 electrons in the D subshell, and I promised that because of the number of exceptions that take place, we won't go into the Ds in detail in this class. But it's important to know that the Ds are always in the subshell that's one less than whatever period we're working in. We'll see that again in a minute. So let's do first a really simple electron configuration to get us started. Let's just do the electron configuration for hydrogen. Remember, you can find the electron configuration by looking at location on the periodic table. Hydrogen's in period 1. It's in the first group, so hydrogen's electron configuration is just going to be 1 for the period and S1 for the group. If I need to do the orbital filling line diagram with the arrows, remember anywhere I see an S, I draw a line, and because there's one electron, I'm just going to draw one up arrow. Okay, hydrogen's pretty simple, so let's do another one that's a little more complicated. Let's do the electron configuration for carbon. To do the electron configuration for carbon, I can use the shortcut by first identifying how far I have to go with my electrons to get the correct electron configuration. Because carbon is in period 2 of the periodic table, and it's in the P2 group, I know that the very last thing I'm going to write for my electron configuration is going to be 2p2. And I basically have to write all of the electrons and their configuration prior to 2p2. I like to use the shortcut. Since carbon's in period 2, I'm going to pick the noble gas from period 1. That's helium. So there's my noble gas shortcut. And because helium's number 2, I now pick up where that left off. I'm in period 2. I need the S subshells. And that subshell is filled, so I'm going to use both of them, 2s2. And now I go across, and here's my 2p2. If I need to do the orbital filling diagram, I draw one line for the S. It gets an up arrow and a down arrow. I draw 3 lines every time I see a P. And I always fill up arrow, then an up arrow. And if I kept going, I would do a third up arrow before returning to the first line to do a down arrow. So this is the electron configuration for carbon. Let's try another one that's even more complex. Let's do the electron configuration for sulfur. If I look at the shortcut using the periodic table, I can see that sulfur's in period 3 and it's in group P4. So when I write my electron configuration for sulfur, the very last thing I'm going to write will be group 3, and it's in subshell P, and it's the 4th electron that goes into subshell P. I have to write everything that comes before that, but I can take advantage of the noble gas shortcut. So since sulfur's in period 3, I'm going to go for the noble gas in period 2, which is neon. And now I'm going to pick up where neon lives off at electron 10 and go down to atomic number 11. So this is my third shell. I'm going to start with the S's. I need both of them to get across the row, 3s2. There's nothing else in this row until I hit the P's, and I already have that. So even though this is a little spread out, this is the electron configuration for sulfur, 3s2, 3p4. If I want to do the orbital filling diagram, I draw one line for S, up, down, and then I draw 3 lines for P, up, up, up. That's 3, and I need 4, so there's my 4th. This is the electron configuration and orbital filling diagram for sulfur. Now let's do one that includes that D subshell. Let's do the electron configuration for bromine. Bromine's starting to be a larger atom because it has 4 shells because it's in the 4th period of the periodic table, but I can still use the shortcut in order to see where I'm going. So the electron configuration for bromine, because bromine's in period 4 and it's in the group that corresponds to P5, the very last thing I'm going to write is going to be 4P5. Now I have to write all the electrons in the electron configuration up to that point. To use the noble gas shortcut, since I'm in period 4, I look at the noble gas in period 3. It's argon. Now I pick up where argon leaves off. Argon's atomic number 18, so I go down to 19, which is potassium. This is in period 4, and these are the S subshell. I need both of them, so I'm going to write 4s2. Now I end up in the D subshell as I'm working my way across. Again, for our class, we're not going to worry about stopping at any point during the transition metals as we count across, so I can just write that these are the D10, but I have to include the period number. This is where the N-1 comes in. Because I'm in period 4, these are actually the 3D subshell. So I'm going to write 4s2, 3d10 before I return to 4p5. This is the electron configuration for bromine. To do the orbital filling diagram, I draw 1 line for S. For D, I'm going to have to draw 5 lines, so I'll try to fit that all in here. For P, I need 3 lines. And it's okay if you're working on these to kind of draw some lines to keep them straight. For the S2, I need an up arrow and a down arrow. For D10, I'm going to do up, 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 up. That's 5. Here's 6, 7, 8, 9, 10. These are always going to be filled when we're dealing with them in our class. In more in-depth chemistry classes, you'll go into those details. And then 4p5. So 1, 2, 3, 4, 5. This is the electron configuration for bromine. Let's do 1 or 2 more that are a little bit complex to see if you've really got it down. Let's do the electron configuration for tin. Tin is in period 5, and it's in group 4, which is the P2 group. So I know that the very last thing I'll write in my electron configuration is 5p2. I have to write all of the electron configuration up to that point. So since I'm dealing with period 5, let's do the noble gas shortcut by selecting the noble gas in period 4, which is krypton. I pick up where krypton leaves off at number 36, so I go down to number 37. This is 5s2. Then I go through the D subshell. Remember, these are N-1, so because I'm in period 5, these are the 4 Ds, and I need all 10 of them to get all the way across this row. That brings me to the 5 Ps, and as we said, I need 2 of them. Again, if I want to do the orbital filling diagram, 1 line for the S, up, down, 5 lines for the D, and even though we draw the up arrow first, it won't make a difference because these are all filled. And then 3 lines for the P, and I need 2 up arrows. You can do half arrows or normal arrows, doesn't make a difference. This is the electron configuration for tin. Let's do 1 more. Let's do the electron configuration for radium. Wow, that's pretty far down the periodic table. Don't panic. Remember, you can use the periodic table and the location of the element for a shortcut. So I see that radium is in the 7th period, and it's in the group that corresponds to S2, which is group 2. So I know that no matter how long my electron configuration is for radium, the last thing I'm going to write is going to be 7s2. But even though it's pretty far down the periodic table, we have the noble gas shortcut to make this a lot faster. So since I'm in period 7, I'll take the noble gas that was in period 6, that's radon, write it in parentheses or in brackets, and then I have to pick up where that left off, which look, it's already 7, and I'm at 7s2. So in fact, this is the entire electron configuration. To make it look a little bit neater, I can actually just move this over. But it's really short because of the fact that, that radium is so close to the left-hand side of the periodic table. If I want to do the orbital filling diagram, S requires 1 arrow to represent the orbital, and there's 2 electrons in it, so 1, 2. This is the electron configuration and the orbital filling diagram for radium.